Welcome students to the series of lectures on statistics. And in this series of lectures on statistics, we have so far completed discrete probability distribution. We entered into continuous probability distribution. And also in the continuous probability distribution, we completed one distribution, that is normal distribution. And now we are entering into t distribution. So let's focus on t distribution. Now, the only question that you should be asking yourself when you enter into t distribution is that why on Earth we have to use t distribution when we have such a pitch perfect normal distribution which is already existing in the world? Why we cannot do our prediction with the help of normal distribution? Why we have to move to t distribution? This is the question number one, and this is the only question that you should be asking. And if you try to ask this question and try to understand what is the rationale behind that, why we cannot use normal distribution, you would understand why to use t distribution and when to use t distribution. Okay. See, the only problem with the normal distribution is that, first of all, it is too perfect. And the second is that it neglects certain randomness of this world. Okay. It neglects the uncertainty of the world. So the prediction that comes out of the normal distribution is simpler, easier, and also perfect. But normal distribution has to understand that yes, there are certain randomnesses in the world, there are certain uncertainty in the world, and for that we have to fall back to a much worse distribution than normal distribution, and that distribution is a t distribution. Now the question is, what is that normal distribution is neglecting or disrespecting? The uncertainty, but what uncertainty? So what it does is it says that assume this is a population, assume this is a population, just a second. This is a population. And if in this population, you can keep on taking different sample, random sample. If you take the mean of these sample, which is X bar of these sample, this is uncertain. Sometime it could be 2, sometime it could be 3, sometime it could be 4, sometime it could be 5, or it could be any number. But on an average, it would be equal to the population mean, but it respect, the normal distribution respect that the sample mean is random. But it doesn't respect another concept and says that the variance the variance of each sample is fixed and constant. It is not random. So S1, which is the variance of sample 1, S2, which is the variance of sample 2, S3, which is the variance of sample 3, and S4, and so on and so forth, all the variance, all the standard deviation is fixed and constant, which we all know is not correct. The variance is also uncertain because if you take a sample and calculate the variance of different sample is not going to be identical, or it is not going to be even similar. It would be different. Sometimes it would be 1, sometimes it would be 2, sometimes it would be 3, so on and so forth, right? So the simple intuition to, or the simple rationale that why one should be using normal distribution is that this world, the data has a lot of uncertainty, has a lot of randomness, which normal distribution does not respect. Yes, it says that the mean of the sample is random, but it disrespects that the variance of the sample is also random. Normal distribution assumes that it is fixed. Okay. The another problem with the normal distribution, this was one of the problems. The another problem with the normal distribution is that the normal distribution comes into the picture statistically, mathematically, when the sample size is greater than 30, as per the central limit theorem. Now we know that every time we don't have that liberty, that luxury to have the sample size of greater than 30. So whenever there is a sample size which is less than 30, what should we do? We should say that we cannot use any distribution. We cannot say that. We have to use certain distribution, and that distribution is t distribution, which also have a similar bell curve shape like normal distribution. It has a bell curve shape like normal distribution. Even here, the left and the right section is symmetric, as in the skewness of the data of this distribution is also 0. This point is also the mean, the median, and mode, but it is not normal distribution. It appears like normal distribution, but it is not normal distribution. It is a much worse or much worse distribution than the normal distribution. Okay. So we cannot use a perfect bell-shaped curve, that is the normal distribution. We have to succumb to more uncertain distribution, which respect more uncertainty in the world, that is the t distribution. So what is the flow? The flow is there is more uncertainty in the world. The sample size cannot be always greater than 30. The variance cannot be fixed. So we have to move away from normal distribution. We have to move away from normal distribution and should go to a distribution which would be a bad distribution than normal distribution, much worse distribution than normal distribution. If the uncertainty is low, okay, perfect, use normal distribution. But if the uncertainty is increasing, you have to go to a distribution which does look like normal distribution, but it is not normal distribution, and that is a t distribution. So you have to move farther from the normal distribution, from the normality. Now, what it means that if you're moving away from normal distribution, which is a pitch perfect distribution, you're moving to a distribution which is a bad distribution, relatively bad distribution than the normal distribution, then the confidence in that distribution decreases because it is a bad distribution. So, less confidence in that distribution. If there is a less confidence in that distribution, your prediction quality will increase or decrease. The prediction quality will decrease because now you're working with a bad distribution. And there is no option because there are more uncertainty and randomness in the world. That's why you're falling back to a bad distribution, which respect the uncertainty and the randomness of the world. And that's why you have a distribution where you have a less confidence. If you have a less confidence, then the prediction quality of that distribution would be much worse than the normal distribution. So the distribution that you will go to will have a wider confidence interval. Now, this is very critical, very, very critical. The distribution that you will go to will have a wider confidence interval, wider, not narrower, wider confidence interval. This concept is slightly difficult to understand. So we'll try to understand with the help of one example. Why? Because your prediction interval will increase. You will understand that how the prediction interval, the confidence interval will increase. But you should understand the rhythm that you're moving from a good distribution to bad distribution. If you're moving to a bad distribution, the prediction quality decreases. The prediction quality decreases means statistically that the confidence interval would be wider. And we'll see with the example how the confidence interval, the prediction interval would be wider with the help of one example. But that is a rhythm. That is the flow. Now, if you have understood that you're moving away from a good distribution, where does it stop? Where does it stop? How bad the distribution could be? It depends upon what? The central limit theorem. The central limit theorem says n should be, the sample size should be greater than 30, right? It says that n should be greater than 30. The sample size n should be greater than 30. And then you can use normal distribution. Perfect. Awesome. But what if the sample size is 30? If the sample size is 30, you have to fall back to t distribution. It is a bad distribution. Okay. So if it is normal distribution, you fall back to a wider distribution, which is a t distribution. But what if the sample size goes to 29? Will you use the same distribution? No, the sample size decreases, the uncertainty increases, the randomness increases. You have to fall back to much worse distribution than the t distribution you were using in n equal to 30. So you will use much wider distribution. So definitely a distribution, the t distribution should respect if the sample size is decreasing, the quality of distribution further decreases, further decreases, further decreases, and it should keep on decreasing. It should be like for n equal to 30, this is the t distribution which you can use. But if the sample size decreases further, you cannot use the previous distribution. You have to use a much worse distribution than the previous t distribution, which would be much wider distribution than the previous distribution, t distribution. Even this is the t distribution, but it is a worse t distribution than the previous one. And if n is 28, again, you have to fall back to much worse distribution than the previous t distribution. Now you're working with t distribution, but t distribution is not just one distribution. It is a family of distribution. What? A family of distribution that respect this concept. That if the sample size is decreasing, I'm not going to give you one distribution, one single t distribution like one normal distribution. I will give you different wider distribution. See, the peak is getting further down and the distribution is getting further wider. All these distribution, which you see are t distribution, but this is for sample size 30, this is for 29, this is for 28, this is for 27. So t distribution is not one distribution, it is a family of distribution. Super important concept. Now, what is actually happening? If this red curve is normal distribution or normally distributed, then what you have to do, you have to pull the left and the right tail of this distribution. Assume this is a string and you're pulling the left and the right tail of the string. What will happen? What will happen? It will approach the green distribution. Now, this green distribution is one of the t distribution from the family of the t distribution. You can keep on stretching this thread. The peak will get lower, lower, and lower, and the tails will become wider, wider, and wider, and fatter, fatter, and fatter. So fatter tails. What is the meaning of fatter tails? The meaning of fatter tails is that the probability of the extreme left and the right outcome has increased in the t distribution. Why? Because it is a bad distribution. That's why the outlier probability has increased. Okay. Now, what do we have to understand? We have to understand that why wider confidence interval? Why wider prediction interval? And we'll try to understand with the help of one example. So the example says that the portfolio has a mean return of 5%. So there is a portfolio where have number of stocks, say 100. So you have a portfolio, you have multiple stocks in this portfolio. Okay. Multiple equity in this portfolio. Some would be like Tata Steel, other would Meta, other would be TCS, whatever. And the mean return of that portfolio is 5%, and the standard deviation of the portfolio is 3%. What do you have to do? You have to do a prediction. Prediction with a probability or confidence of 95%. You have to do a prediction with the help of a 95% probability or 95% confidence. So you have to state in a term like, I'm 95% sure that the stock return will fall between this and this, or I'm 95% confident that the stock return will fall between this and this, or I'm 95%, there is a 95% probability that the stock return will fall between this and this. You have to do the prediction something like this. So you have to do the prediction in three different scenarios. The scenarios are, first scenario is if the portfolio return is normally distributed. The second is if the portfolio return is t distributed with a sample size of 30, which could be thought as like, okay, you cannot use normally distribution assumption of the portfolio return, or you cannot assume normally distributed portfolio return. You are falling back to t distribution, but the sample size is 30, which means that the portfolio has 30 stocks, not 35 or 40 stocks. Or you can think of that the days of the returns that I have chosen to calculate the mean return is 30. It's not greater than 30. So you have to fall back to t distribution. And the third scenario is if the portfolio return is t distributed, but the sample size is 20. You should only, thematically, what you have to understand, when the portfolio return is normally distributed, your confidence in the prediction would be higher, which means that your confidence interval would be narrower. We'll understand. Which means that the confidence interval would be narrower. But when you move to t distribution with a sample size of 30, your confidence in the distribution decreases. That's why the confidence interval will increase, or the prediction interval will increase. Now, if you further fall back to a distribution with a sample size, t distribution with a sample size of 20, your distribution would be much wider and the confidence interval will be much wider. So these are the three distribution. This is the first distribution, which is normal distribution. I said the mean return is 5%. And I have to cover 95% probability. When I cover 95% of the probability, which means I have to symmetrically move in both the direction from 5% such that I would be able to cover what? 95%. Now, if you cover 95% of the area, then what will happen in normal distribution, that this point will come as negative 0.88%, and this section where the 95% or basically 47.5% will cover in the right direction, this section will come as 10.88%. Now let's speak in the terms of prediction. I'm 95% sure. What it means is I'm 95% sure that the portfolio return will be between negative 0.88% and 10.88%. That is the meaning of the prediction with the help of normal distribution. So this is the prediction. See the range. The range is important here. That is the confidence interval. This is the confidence interval. This is the confidence interval. What is the confidence interval? The range of prediction. The range of prediction is the confidence interval. Is the confidence interval. So if I'm saying the range of prediction is between negative 0.88% and 10.88%, I'm saying I'm 95% confident about it. Or I can say there is a 95% probability that the portfolio return will vary between negative 0.88% to 10.88%. Now, what about this? This is the second scenario. What was the second scenario? The portfolio return is t distributed. Okay, again, you have to cover 95% of the area. So I'm covering 95% of the area. Now, if I cover the 95% of the area, symmetrically, this section would be 47.5%, this section would be 47.5%, and the total area would be 95%. The total area would be 95%. Then this point is not negative 0.88%. This point is further left from 0.88%. Negative 0.88% would be somewhere here. It is further left, and it is saying I'm negative 1.13%. And this is further left than 10.88%. It is 11.13%. Why that has happened? That has happened because, see, in the T distribution, the peak becomes lower. So the tail has to be fatter. So to cover the same 95% of the area, you have to move into the tail. So when you're moving into the tail, then what is happening? Your interval, the range of prediction has increased from negative 0.88 to 10.88 to negative 1.13% to 11.13%. Now, when you say in the terms of probability, you will say I'm 95% confident that this portfolio return will vary between negative 1.13% to 11.13%. So your confidence interval has widened. Why it has widened? Because the probability distribution becomes wider. The tail's probability are fatter, or the tail has more probability into it. So you have to move into the tails of the distribution. Now, this is only for the sample size of 30. Now, this is a t distribution with a sample size of 20. Right? This is scenario number 3. If the portfolio return is t-distributed and sample size is 20. If you're moving to sample size of 20, you have to stretch the tails further. So the peak will become much lower than the previous distribution, previous t-distribution, and the tails will become more fatter. Now see what is happening. If you try to cover 95% of the area, that area, if you move symmetrically in both the direction, this section would be 47.5%, this section would be 47.5%, moving symmetrically. And when you cover the 95% of the area, then see, it's further stretched. Your confidence interval are much wider, negative 1.26% to 11.26%, much wider than negative 1.13% and 11.13%. It is negative 1.26% and 11.26%. This is the range of prediction, further wider. The confidence interval becomes wider. Now you'll say I'm 95% confident that the return will vary between negative 1.26% to 11.26%. Your prediction quality has decreased. Why it has decreased? If you're more confident in the narrower range, that is the quality of the prediction. If I can say that I'm 95% confident that the return will vary between 4% and 6%, that is a confidence in the prediction. Because now I'm saying it will vary only between 4% and 6%. I cannot say even in the normal distribution. I don't know which distribution to be used, but I cannot say that in the normal distribution. So if I'm 95% confident with a wider range, then my quality of the prediction has decreased or decreasing. And it is decreasing because the sample size has decreased. So what do you need to understand? The most important thing you need to understand that t distribution is a family of distribution. See, this one might be for sample size 30, this might be for sample size 29, this might be for sample size 28, right? And actually they do not say sample size 30, they say degree of freedoms. Sophisticatedly, they say degree of freedom, which is nothing but sample size minus 1. So they won't say sample size 30, they will say sample size 29. Sorry, degree of freedom 29. They won't say sample size 29, they will say degree of freedom 28. They won't say sample size 28, they will say degree of freedom as 27. So degree of freedom is always n minus 1 in the case of t distribution. So I know we haven't entered into further examples of the t distribution, but this explains why we need t distribution. Whether t distribution is a single distribution or multiple distribution. It also explains that when you enter into the detailed prediction with the help of t distribution, you don't have one distribution. You have different distributions of t distribution, a family of distribution of t distribution, which is dependent upon the degree of freedom, which is sample size minus 1, right? And therefore, there would be different tables that you have to study and read to do the prediction of with the help of t distribution. And that is what we'll discuss in the next session, that how to do the prediction with the help of the t table, the same way we were doing for z table, which is for normal distribution. Okay, with that, I'll pause the video here. Thank you. Have a nice day. We'll meet in the another session where we'll do the prediction with the help of t distribution. Thank you.